Hello and welcome back. We are going to learn today two very fundamental issues in studying R, and these are use of functions and objects in R. Think of functions and objects as kind of cellular units because you will need functions at every point in working with R. Functions are kind of building block of how you work with R. And objects are kind of codified units in R, which you will be manipulating in order to use R effectively. In this set of lectures, on this deck of slides, you will learn about what are meant by objects, what are meant by functions, how to write a function, and how to manipulate objects in various functions. What immediately will follow this short introduction is the deck of narrated slideshow, and then afterwards I'll run a series of exercises which will be in the form of screenshots and screen grabs, which you will learn. Please practice based on those screen grabs in your own installation with R, and let's get started on this.
Hello and welcome to this edition of Learning About R. We are going to learn about objects and functions in R. In this module, we shall start with describing the idea of objects. Next, we shall learn about different types of objects. Then, we shall learn about functions. We shall learn how to write functions in R. Objects, data, and functions together make packages in R. We shall also learn hands-on how to read a data frame in R and how to use objects and write functions. We recommend that after watching this set of slide decks, you switch over to watching the hands-on and screen recording and screen grabs, and then you practice using R Studio or an R console and script editor what we show on the screen captures and the screen grabs. Now, objects and functions in R are like the cells in our body, and you know how the cells action in our body. Cells, of course, in our body are our building blocks. Cells and cells together with the tissues and organ systems are kind of organic, and they perform many activities that keep us alive. Very similarly, think of R as an organic entity, and you will see that in R, R has got objects which perform as building blocks, and these objects are manipulated in functions which are like the actions. Objects, specifically in R, are containers of data. So as you can see, there is a way in which you can assign a particular set of data or information into an object. The way you do this is you use like a little arrow, and then use a dash, and then an arrow that should point to left, and a dash associated with this. And so any entity, any information which is present on the right side of the combination of the arrow and the dash gets stored into the named object which lies on the left hand side of that. So that's why we say that we use assignment operators with an arrow that points to the left and a dash to assign values on the right hand side of the assignment operator to store data on the left hand side. There is a saying in R that in R everything is an object and all objects belong to classes. This is a very important adage that you must remember when you work with R, because it's really the crux of working with R. As we just noted, everything in R is an object. So because everything in R is an object, therefore what R does is R provides a big space. So anytime you open the R software, you will see that R actually gives you a blank white space. It does not start with a spreadsheet. It does not start with a number of different buttons all over the place that you can see in some other software. R basically starts with a wide open space, and in that wide open space, you can write anything that you want. And any information that you space in that wide open space becomes information bits that can be stored in the form of objects. So basically we say therefore that R provides you a space for holding these objects. Now this space which R provides the user to write codes, write functions, add objects, add data points, add any information, we call this workspace. So in R this is known as a workspace. And quite obviously, in the workspace, you will have to work with several different types of objects in course of any data analysis that you do. And it is quite natural, therefore, that when we work with so many objects, we should have a plan to organize these objects. Therefore, these objects are organized into entities, and these entities, in which the objects are kind of classified, organized, are known as classes. Now, if you want to find out what objects exist in the workplace, because quite often people have used the workspace to do a lot of calculations, a lot of functions. For a small data analysis project, it may not be much of an issue, but sometimes we need to work with large sets of objects and complex data analysis, complex functions. It is quite obvious that you would like to find out what objects exist in that workspace, whether there are conflicts in the names of these objects, etc. And in order to do that, you use a function, and that function is either ls and then you open and close a bracket, or you type objects and then you open and close a bracket. And to find out whether a particular object belongs to a particular class, you use another function, and the name of that function is. So you'll say is.numeric and then open and close the parenthesis, and within that open and close parenthesis you write the name of that particular object. So if for example x is given a value of 1 and then you write is.numeric within parenthesis x, then it is going to return as true because x was given a numeric value, something like this. So next we are going to learn how we can name objects in R. Now, before we get into the steps of naming an object in R, we need to remember that R has got several inbuilt objects. When R was written, or when R gets written in each of its iterations of the versions, programmers and software developers who develop R, they of course recursively add objects within R. So these objects are inbuilt objects. Now, the way the inbuilt objects are named by the R developers and R creators, these are called reserved words. And these reserved words are the words which you cannot use to name another object that you as a user are going to use. For example, if you wanted to name an object as if, then you would not be allowed to name an object as if, because if is already contained within the R as a reserved word. Another example is as you've seen, words like as or if or and, etc. For. These sort of words are contained within the namespace of R, and these are reserved words. So there's something important to keep in mind. So you cannot use the word if to name an object in R, right? And it is quite obvious that you may not be able to know all the different names of objects that are already contained in the namespaces as reserved words in R, although you can get a list of them, typing the help.start and then browsing down to the namespace and named objects or reserved words. But in general, it is always a good idea to start name of an object in R with a capital letter and then use it. So all inbuilt words start with small letters. Therefore, to avoid clashes with reserved words, start names of your objects with capital letters. The other tip is this, that when you name objects in R, try to name them so that you describe what is about to happen to them. Say, for example, if you want to find out about a correlation matrix of a regression equation, say for example, you just use the object name as cormat, for example. Okay, if you're describing some data, write like my data or the data or this data, because that's the nature of that particular object. So either nature or whatever it's going to happen to those things. Do not start a name with numbers. So if you want to name an object, do not start a name with a number like 1, 2, 3, foo, for example here. Do not write anything like this. Okay, so that's number one. And the other thing next that we're going to learn is you can actually change the nature or type of an object in R. And that's quite interesting and very, very useful. So you can transform one object in R or one type of an object in R to another type of an object. For example, let's say you have used X and you have used an object X and you have named object X or you have set the value of object X to 1, but you put the 1 in between quote marks, so the number 1 or the figure 1 has now become a text. Obviously, if you type is.numeric x, then it is going to return that it is false, that it is not a numeric variable anymore. So what you want to do then is to convert that numeric value that the letter value x or text value x into a number value x. So in order to do that, you use a function which is known as.numeric. So as basically tells you is what is it that you want it to be, and numeric or null or logical or character or vector. We'll see what these are in course of time as what it is that you transform it to. So for example, a number can be treated both as a numeric variable or as a string variable, and we have just seen how you can convert in between the two. So you could start with a number as a string and then set it as a numeric variable by using the .numeric function, so as.numeric function. And this list, for example, shows you a number of different such functions. So for example, as.numeric will convert the object to a numeric vector. Okay, if you got as null.x, it's going to convert it to a null one. So if you want to do it as a logical vector, say for example, you convert x as logical, and you see that if the x has got a value of greater than 1, that will be set to true, otherwise it's going to be set to false. You can also take x and set it to 1 and then convert that into a character vector. So x, as character, and it's going to behave as a character vector. So we can do all of these things. Very, very useful is if you take a matrix, we'll learn about matrix in a second, and then convert that into a data frame, and you can say that as.data.frame, and then within parentheses at the value of at the name of that particular object. And when you do this, then you can set any matrix in the form of a data frame. So these are really, really very, very useful ways in which you can transfer or convert one object to another. Now, as we noted, everything in R is an object, and all objects have got classes, right? So all objects belong to classes. In this particular case, we note that there are 4 major classes of objects in R. The first class is vectors. Vectors are like strings, very simple, one-dimensional array of similar objects. For example, if you have got, for example, a name, somebody's name is a vector. And if you've got 2 names that are strung together using comma or separated by comma, then those 2 names will constitute a vector. It's just a very simple string of vector. For example, you can see that in this particular graphic, look at the square box with each of these square boxes. Each of them are vectors. That is, the region country contains the name of countries and regions. The program type, that is NS or S or N, this is a type or a factor kind of an object, but it's a vector again. And of course, the years in which the programs began, for example, in this hypothetical data set, these are numbers, and these numbers also form a vector. Compared with vector, there are matrices, and the matrices are 2-dimensional arrays of vectors. And then we have got lists and data frames. These are spatial classes of objects. And then, of course, so each of these examples is a vector in this particular case. You can certainly name other vectors in the course of your data analysis. Let's continue to learn about vectors. Vectors contain the same type of information. So vectors are very basic data storage units. Almost everything in R starts with a vector. Therefore, to reinforce once more this particular piece of lesson, we see that each column in this particular data frame is a vector, as each column contains a variable. And the variable contains only one type of information. So if it is a name variable, then it will only contain string variables. If it's for example year variable, then it's only going to contain year or time variables or that kind of data. So similar type of data strung together consists a vector. The next level of organization of information in R from vectors is matrix. A matrix is a very simple table-like structure. And matrices have got rows and columns, and matrices are two-dimensional. Like vectors, matrices contain only one type of information. So as you can see here, the dark column on the left side, you can see that you can convert a string of numbers into a matrix. And the way you do that is that you put together a string of numbers by the function called C, which is known as catenation functions, or you concatenate a string of numbers into one, and then you specify another function called matrix, so you can actually embed functions within another function, and then you specify how many rows you want. In this case, we want only 2 rows, and then we organize that information in the form of rows. So what will happen is, if it is 1, 2, 3, 4, 5, 6, and if we organize it by rows, in the first row we'll put the first 3 numbers because we need only 2 rows. So in the first row we'll have 3 columns, 1, 2, 3, and in the second row we'll have another 3 columns, 4, 5, 6. It would be different if we were to organize this in the form of columns. So in other words, if we said that by row is equal to false, then you would have 1, 2 in the form of columns, because now we're going to organize in the form of columns. So it'll say, okay, there's still 2 rows, so there are 3 columns, and we'll have 1, 2, 3, 4, 5, 6 in the form of 3 columns. So this is a very, very simple way in which you can put together a matrix. Next, we're going to try and study lists. Lists are a special kinds of classes of objects in R. And you can see in list, you can have the same structure as a vector, except in vector you will have very similar kinds of objects. In list, you can have different kinds of objects. So a list is a mix of different types of objects. As you can see here, in a data set, the rows are almost always lists, unless the data set contains only one type of objects, that is only numbers, say, for example, then it doesn't matter. But in most circumstances, we have got data frames, or in a data set where you have different types of objects all in the form of columns and stacked together. In this particular case, for example, we have got a data frame which has got region or country information, which has got information about whether a program, the type of a program that's developed, and the year when the program started. And you see that in each row, for example, in the first row, we've got Australia, NS, and 1991, which says that an NS type of program started in 1991 in Australia, and these 3 things together form one row, which is a list. And there are several ways in which you can subset the lists, you can cut the lists. We'll see in a second when we start working with these things. And then the next thing that we're going to learn here is about data frames. Now a data frame, as we have just seen, that a data frame is a combination of the rows and columns. So when the rows and columns are put together, they are like a step above from the matrix, because in a matrix we have only one kind of objects, whereas in a data frame we can have a number of different types of objects all organized in the forms of rows and columns. So as we saw in R, this means lists and vectors. And when we combine them, we get data frames. When you do data analysis, you will invariably have to deal with data frames. So data frames are the first or the most beginning steps in which you will obtain data into R from wherever. It could be from some inbuilt data sets into R, or it could be some other data sets, that you can find, or you can grab a data set from the web. Be that as it may, you can just bring them into R, and then you can work with them. So the data frames are the beginning steps of your data analysis. Next, we're going to learn about workspaces in R. And when you open an R environment, it, as we started saying, that it gives you a blank canvas. And this blank canvas is actually your workspace. And hidden behind that blank canvas is a space where you can store all the objects. And this space is a global R environment. So our workplace is also known as a global R environment. And after you have done your work in sessions in R, that is, you set aside chunks of time that you will be using to put work in R, you can actually then write all the codes and save that session. And the way to do that is to use an extension which is known as R data. So you name the session, maybe the project that you're working on, .R data, and then when you come back next time to R, in the particular folder where you were using R, you can open that R data session and everything will come back to you. And so you can then use the script that you've been using, all the objects are then restored, and you can find all the objects using the ls or objects function. So that makes it very, very easy and modular to work with R. So now let's learn a little bit about functions in R. Of course, functions in R are better demonstrated than spoken about. But basically, functions, as in any function, anywhere in any other programming language, are about actions that R will execute. So you will provide some instructions to R that the R project will execute. And those actions and those recipes are what are known as functions. One of the other important things that you need to understand is this, that all functions are also stored as objects. And the way to write functions is this, that you first define an object in which you're going to store the function, then write the word function, and then open a curly bracket, and then write all the instructions, and then close the curly bracket. It's just that. And next, when you call a function, what you do is this, that you remember the name of the function or the name of the object in which the function was stored, and then you open and close parenthesis, and then specify whatever variables that should go into this, and whatever other units that should go into that within those parentheses. So you will all the conditions and all the statements that should go into the functions. But when you call the function, all you need to do is just type the name of the function, open and close the parentheses, and then put in the particular parameters that are present in that particular function. So now that you have learned a little bit about objects and functions, and we'll see some hands-on examples soon, let's go for a quick recap. The recap is this, that everything in R is an object. All objects have got classes, and we learned that we could write functions. We learned that there are different kinds of objects that we should know, and in general, what we need to do is this, that we should be using the objects and the functions to develop the plans of our data analysis. So we stop here, and then we move immediately to the hands-on screen grabs and screencasts. Take a look at this and then practice on your own. Thank you very much for paying attention to this. When we start with R, we always use, we set the working directory. As in this particular case, we can see that we set the working directory to, a specific folder within our computer. And you can also see, as we saw before, that R can be used as a calculator. So if you use print 720 times 360, R will come back and produce the number that is there. Here is an example in which you can actually load a package. The package in this particular case is psych, PSYCH, and we say require, and this loads the package, and all the functions that are here will be loaded. You can actually load an entire data set and then store it into an object. In this particular case is my data, and we use a function read.csv to store the objects. And the read.csv is a function that reads comma-separated value files. The value file, or the comma-separated value file in this particular case, is a file called work.conds.csv. And these are the parameters that you pass into this particular function so that the contents of that file is stored in this single object. Here is an example of a function that you get to see. So paste.table is a function. You can see that it starts with specification of the word function with an opening and closing of parenthesis. Then you open it with a curly bracket, and then you write all the conditions of the functions over here, and then finally you close the bracket. So my PCT, for example, is an object where you store the things like and you can store the functions, for example, the total as well as areas of concern, etc. Those variables are stored here, and a percentage is calculated. Names my data. Names is a function which will read the variable names of a particular data set. In this particular case, this is the object my data, which contains the variables, and you can see that these are in the form, this is a vector. As you can see that C is a function which concatenates the conditions, VLS, etc., all of these words together. You can actually use a function in order to generate a plot. You can see here that a plot is generated when this was run off. So this was a very brief and quick introduction to understand the different kinds of functions and objects that R uses. Thank you very much, and play with more functions and objects, and if you need more help, click on the help files. Thank you.
As we have just seen that we learn how to use functions, we learned that when you use functions that you use specific notations, that you give the function a name. Each function is an object, therefore you learned what objects are, how many different types of objects are there in R, and then how to use functions to write separate objects and then call them in various places in R. Now that you have got two fundamental building blocks of R well sorted and understood what these are, we are now going to explore the use of the functions and the objects in doing regression models and other kinds of data analysis. So we'll get started next in those two modules. Thank you. Stay tuned.